Our next theorem tells us how to calculate the amplitude and period of a sinusoidal, so like a sine cosine function. So if omega, that's what this symbol is, this is lowercase omega, is greater than 0, the amplitude and period of y equals a sine of omega x and y equals cosine omega x are given by amplitude, right? Amplitude is going to be the absolute value of a. Remember, we use the absolute value to take a measure of distance, right? And if we were looking at a graph, that amplitude would never want to be negative. It's really just a measure of like distance between the midline. Period, also denoted t, is 2 pi over omega. So let's go ahead and calculate the amplitude and period of this function. I have y equals 5 sine of 3x. So my amplitude, I'm going to shorten that to a and p, is the absolute value of 5, which is 5. Our period, which I need to get used to denoting as capital T, is 2 pi over omega, which in this case is 3. So our amplitude is 5, but our period is 2 pi over 3. Next, we're going to find the equation for this sinusoidal graph. So I am told what its period is. Its period is 4. So 4 is 2 pi over omega. And its amplitude is going to be 2. And I'm going to have a function of the form y equals, is this a sine or a cosine? Well, this is actually a sine, right? Because sine of 0 is 0. So I have y a sine omega x. So I have y equals 2 sine omega x, but I don't know what omega is. I have to solve for this. And I can do that using this equation. So if I have 4 over 2 pi over omega, multiply both sides by omega, I get 4 omega is 2 pi, divide both sides by 4, omega is pi over 2. So I have pi over 2 x. That would be the equation for this graph shown. Last but not least, let's graph the y equals 3 tan of 2x. And we're going to use this graph to determine the domain and the range. Always get used to stating your domain and your range. If I didn't do that for the earlier problems, I do apologize. But remember, the domain of sine and cosine goes from negative infinity to positive infinity, and a range is affected by the amplitude. So I have y equals 3 tan of 2x. Okay, so let's go ahead and graph tangent of x. Then we'll graph 3 tangent of x. And then we'll graph 3 tangent of 2x. Remember that 2 is our vertical stretch. And 3 is our vertical stretch and 2 is our horizontal compression by a factor of 1/2. So typically the period for a tan function is pi. So I have vertical asymptotes for tan of theta at pi over 2, right? Because that would mean that x is 0. I also have one at 3 pi over 2. Tan of 0 is going to be 0. Tan of pi over 4, let's label some points, is 1. And my graph looks like this, right, as I approach an asymptote. Tan of 3 pi over 4 is -1. Tan of pi is 1. Tan of 5 pi over 4 is also 1. So here's our function. and it repeats itself. Here's 7 pi over 4. Next, I'm going to multiply this by a factor of 3. So let's change colors. Let's change to green. So that means 0 stays 0, but 1 becomes 3. Negative 1 becomes negative 3. 1 becomes 0, 0 becomes 0. 1 becomes 3. 0 stays 0. Negative 1 becomes negative 3. So here's our new graph. Notice that my asymptotes have not changed, right? We haven't altered the period of this function at all. But when we multiply it by 2, we do. Now I'm compressing what happens in 2 pi to being in 1 pi. So like everything's being squished. Maybe I shouldn't draw something that looks like an asymptote, but everything's being squished to start over here. So everything moves over by a half. Pi over 2 used to be my asymptote. My new asymptote is pi over 4. And this graph gets squished by a factor of 1/2. 3 pi over 2 used to be my asymptote. Now it's 3 pi over 4. Here's my new asymptote. And my graph gets moved by a half, right? Pi becomes pi over 2. Divide that in half, right? And this one moves over here. This one moves here, right? So my graph is just getting really compressed. And this is kind of what it looks like. Remember, it does repeat itself. Okay, so my domain is all values of x such that x is not an odd integer multiple of, in this case, pi over 4, right? This is where my asymptotes are occurring, and our range is all real numbers.